estimate is Shichen from China, Violet from User, and Jisoo from South Korea, and Tina from China. So let me first introduce our data. Originally, the following experiment was performed on epilepsy patients. They showed a photograph of a rock, paper, scissors gesture cue followed by a 2 to 3 second black screen and recorded the ECoG signal. This process was repeated for 90 times and so we obtained a partial dataset containing 67 total channels, and 60 of them are ECoG data and 5 of them are glove data. So, and we've divided our work into 4 steps: the data analysis and exploration, the pre-processing of the data, and the feature extraction, reduction, and classification. So here's an example of our data analysis pipeline. We extracted various time windows from the original about 7-minute sample and performed analysis on both frequency domains, time frequency domain distributions. So, and here is our pre-processing details. First, since the reference paper that given to us suggested us to exclude some high impedance signals, but we found that it's not quite realistic since we only have the recorded signal result and we don't have the electrode hardware information, which makes it difficult to really analyze the impedance of the signal. And so we go ahead to use the Butterworth bandpass filter to extract from the 50 hertz to 300 hertz band, including the high gamma frequency band. And then, since the power spectral density analysis shows that here are some interference peaks indicating a possibly noisy region. So we try to implement some notch filters to remove the interference peaks, like here's at the 50 hertz and 150 hertz, 250 hertz. And lastly, we used the whitening filter to try to strengthen the high gamma band signal and to average the power spectral density. So next, for the feature extraction and reduction part, of course, the common spatial pattern and PCA are quite popular method for feature extraction and reductions. Other than that, we also introduced the Raman space feature extraction and RKSH to do the feature reduction. And then for and here's our classification models. It's also worth mentioning that the time variant LDA is an innovative method from our reference paper. We tried. It took us a long time to reproduce it, and it's lucky that we finally make it. So here's our final result of different combinations of our algorithms. Our result indicates that the Raman and RHKS feature reduction method combined with either of the support vector machine or the time variant LDA classification models give us high performance. And the final highest was the combination of SVN and Raman feature selection method with an accuracy of about 94%. To sum up our project first, I think we're very surprisingly to find that the feature space is much more important than we thought. The feature reduction stage in Raman and RKHS would definitely improve the performance of the classification a lot. And after finding that in the experiment, we tried to read many information about these two mathematical terms, but we haven't really understand the underlying mathematical logic in this as a direction towards our investigation and further application in the future. And second, we actually tried some deep learning method, but to try to do the classification, but the result was not satisfactory. So we found that maybe for ECoG signal, unlike the EEG or ECG signals, maybe like the more simple method may be more useful. And so that's all my presentation. Thank you.
Thank you very much. Very impressive. Angelika, any questions?
Yes, sure. So you showed your classification results in the slide before. So I was wondering whether you have some explanation, why some of the methods outperformed significantly the others.
You mean why this outperforms? Yes. Yeah, actually, we've tried. I've also stated that after doing the experiment and found out how outperforming that, like for example the combination of Raymond and SVM model, we have a quite first stage conclusion that since for the Raymond space, like in this picture, we project our feature on the Raymond tangent space, and so we can keep some of our covariance feature in the Raymond space, and that might be somehow useful for the further classification model after that. But also, as I mentioned before, we haven't totally found out like the mathematical induction or formula behind it. So that's also what we wish to learn after this hackathon. So thank you.